This video expands on my 2021 video, A Summary of the Evidence for Intelligent Design. The video, A Summary of the Evidence for Intelligent Design, begins with a short discussion of the local fine-tuning of conditions on Earth, but then quickly moves to the more powerful evidence from the global fine-tuning of the laws and constants of physics and the initial conditions of our universe.
It is well known and well accepted in scientific circles that the conditions on our planet are extremely fine-tuned for life. The Earth is just the right size, it is just the right distance from the Sun, our Sun is the right type of star, our atmosphere has many rare and lucky features. The list goes on and on. Of course, materialists have a plausible explanation for this. There are many planets in the universe, but only a very few are suitable for life, and we are here because our Earth is one of those rare planets. At least it would be a plausible explanation if the materialist assumptions were plausible, that once you have a planet where conditions are just right, there is a reasonable chance that life would spontaneously arise and intelligent beings would spontaneously evolve over time. But we will see that these assumptions are not plausible. It is also widely accepted that not only is our Earth an ideal planet for life to thrive, but our whole universe is fine-tuned for life. The smallest changes in most of the basic constants of physics, the gravitational constant, Planck's constant, the charge and mass of the electron, and so forth, or of the initial conditions at the Big Bang, would have led to a universe where no conceivable form of life could have arisen. Stephen Hawking, in A Brief History of Time, writes, "The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life." How do materialists explain this? There must be many universes with many different laws and constants and initial conditions, and we are here because our universe is one of those rare universes where the conditions are just right for us to be here. A.J. Leggett lists some of the fine-tuned properties of our universe in The Problems of Physics and concludes, "The list could be multiplied endlessly, and it is easy to draw the conclusion that for any kind of conscious beings to exist at all, the basic constants of nature have to be exactly what they are, or at least extremely close to it." The anthropic principle then turns this statement around and says, in effect, that the reason the fundamental constants have the values that they do is because otherwise we would not be here to wonder about them. Paul Davies, in Other Worlds, writes, "If we believe there are countless other universes, either in space or time, or in superspace, there is no longer anything astounding about the enormous degree of cosmic organization that we observe. We have selected it by our very existence. The many universes theory does provide an explanation for why many things around us are the way they are. Just as we can explain why we are living on a planet near a stable star by pointing out that only in such locations can life form, so we can perhaps explain many of the more general features of the universe by this anthropic selection process. This time, there is no evidence, there can never be any evidence, that there are other universes out there with the same laws of physics but random values for the basic constants, or perhaps random laws of physics also. So the explanation that our universe is just right because otherwise we would not be here to wonder about it is completely unscientific. It is interesting that those who for many years have ridiculed religious believers for imagining that there is another universe, another dimension out there with better conditions awaiting us, have now been reduced by the evidence for fine-tuning to inventing not one, but countless other universes with different conditions. By the way, a number of scientists, for example biochemists, Michael Denton in his 2016 book Firemaker, and physicist Robin Collins in a chapter of a 2018 Oxford University Press book, The Argument from Physical Constants, the Fine-Tuning for Discoverability, are now showing us that the conditions on Earth and the laws of physics are not only fine-tuned for the survival of intelligent beings, they are also fine-tuned for the development of technology and for scientific discovery. Astronomer Guillermo Gonzalez, in his book The Privileged Planet, has shown that the Earth is not only well designed for human survival, it is also ideally situated for viewing the rest of the universe. These fine-tunings are interesting because they cannot be explained by the conditions were just right because otherwise we would not be here to wonder about it arguments. We would still be here to wonder if the conditions on Earth and the properties of the chemical elements and compounds were not so finely tuned to make possible the development of technology and scientific discovery. The only explanation for these fine-tunings is they are gifts from our designer to challenge and entertain us.
The most spectacular example known of fine-tuning comes from Roger Penrose, winner of the 2020 Nobel Prize in Physics, and has to do with the special initial conditions at the Big Bang with the initial low entropy of the universe. On December 5, 2023, I posted some comments at the Discovery Institute website about a friendly debate on fine-tuning between Penrose and Christian philosopher William Lane Craig. At the end of this video, we'll play a 6-minute clip from that interview. Roger Penrose's example of fine-tuning is especially interesting for two reasons. First, because of the enormous precision required. Most other examples of fine-tuning require from a few up to 50 or 100 digits of precision. Penrose's example requires n digits, where n is much larger than the number of atoms in the known universe. And secondly, it's interesting because Penrose does not appeal to the multiverse argument, which is nearly always invoked to avoid the design conclusion. In another video interview with Robert Lawrence Kuhn, Roger Penrose gives one reason why he doesn't like the multiverse argument as an explanation for the incredible specialness of the initial conditions of our universe. Kuhn, that level of precision is so impossible to conceive of from some random point of view. That's not something you can achieve in a random fashion. Penrose, that's right. You can't say, well, there are lots of universes, and out of that, the one we happen to be in, that number was. No, that doesn't explain it. We don't get anywhere close to that number. To get an idea of how many universes would be required to have a chance to explain the specialness of the initial conditions of our universe, imagine a book with as many words in it as there are atoms in the known universe. The probability of a monkey randomly typing out every word in this book correctly is much better than the probability of achieving this level of precision in the initial conditions randomly. So what does Penrose see as an alternative to design to explain fine-tuning? As he clarifies later in the full 2019 debate video, in his answer to the moderator's question here, he is only addressing the other fine-tunings because he has proposed a theory, conformal cyclic cosmology, on how to explain the special and extremely improbable initial conditions without design. He acknowledges there that no one believes me, and indeed his theory isn't accepted by other physicists and is highly imaginative. But he doesn't like the multiverse explanation for the other fine-tunings either, and he does acknowledge that design is a possible explanation, but he just pleads ignorance and says we know so little. Maybe there are other types of life, and thus other types of conscious observers that we can't even imagine, that could evolve in a totally different universe, and he provides a couple of examples from science fiction. When I first heard these comments, I thought something is very wrong with this idea, and William Lane Craig respectfully calls it a desperate expedient. And the problem is not just the difficulty of imagining any form of life without stars or elements heavier than hydrogen, though that is certainly hard enough. In the absence of fine-tuning, there wouldn't even be matter. there wouldn't be chemistry, says Craig. The slightest changes in almost any of the basic parameters of nature would have led to a universe without stable stars or without stars at all, without stable atoms, and thus without carbon and carbon compounds or rocky planets orbiting stars, and most likely without observers. But even if you accept the far-fetched idea that a very different kind of life, not carbon-based obviously, and even conscious observers could conceivably arise in such a universe, that still does not really explain the fine-tuning we see in this universe. We still need design or an incredible amount of luck to explain chemistry and stars and life as we know it. By analogy, would you say that tightrope walking is easy because there may be other safe places to stand? You don't have to stand on the tightrope. Now here's the clip of the interview with Penrose as promised.
First of all, on this question of fine-tuning, which again, we might be worth just spelling out a little bit for the audience. Yes. You've yourself have contributed interestingly to this. There's a certain aspect of reality, the initial low entropy distribution of mass and energy. Now, yes. Without getting too technical at this point, this is essentially the idea you were sort of alluding to earlier, that at that very earliest moment, that singularity in Big Bang cosmology, there's an incredible amount of order versus the disorder, the entropy that appears later on, that needs to be there in order for a life-sustaining universe to be possible. In fact, you put this extraordinary number on it of the precision needed to be 1 in 10 to the power of 10 to the power of 123, which I'm told is, if you were to try to write that down there and you put a 0 on every single particle in the observable universe, you still wouldn't have enough zeros.
Nowhere
on this.
Close.
and so yes. This is mind-boggling stuff, but it appears that as though someone, as you know, who was it who said that someone's been monkeying with the physics? Hoyle, Fred Hoyle said it looks as though, as Bill has said, some sort of design is there to ensure that we got here. Now, what do you say to that idea?
Well, I'm agnostic, I would say, on that one. You see, it's not clear to me. I mean, people talk about even the mass ratio between the proton and the neutron, and the fact that the neutron is just a little bit more massive than the proton, and it goes that way rather than the other way around, and so on. But it's very difficult to, since we only know one kind of life, you see, or one kind of the production of consciousness, it may be very rare throughout the universe. I mean, the numbers may not all be all that good. You see, you can imagine fiddling with them so that there were consciousnesses all over the place. You see, I don't know. You see, we don't know enough about that, and there are some nice examples from science fiction which show different I like the one, Fred Hoyle's idea of the black cloud, you see, where this was a completely different way of imagining a conscious being, which was this huge cosmic cloud which communicated, I guess, by electromagnetic signals and things like this. The other story which I like to refer to is one by Robert Forward, which was a Dragon's Egg, I think was the name of the story, where there was a neutron star which came close to the sun, and the people on the Earth went to explore it, and it turned out that there were living beings on this neutron star, which instead of using chemistry, they used nuclear processes. And this means that their lives and evolution took place millions of times faster than us. And how you can make a story with this complete imbalance was an amazing achievement, I thought. But they even had a religion which took place in the Chelas, which were the inhabitants of this neutron star. And when the Earth came close to them, they built their complete religion on the star, which appeared, you see, in the
So do you think it's I mean, these are obviously stories, but do you think it's possible in a sense that some sort of conscious reality could exist even in the absence of the physical sort of carbon-based life that we obviously need?
It could have been done very differently, in a totally different. You see, there are many different parts of the universe where the physics is very different from what it is on the Earth, and maybe a different kind of life could have evolved there. And I have no idea. Just that we don't know there are puzzles,
Right.
which look like coincidental things. And one of the first ones was Hoyle's thing about the energy level of carbon, which if it hadn't been there, then you couldn't have got beyond evolution.
Well, Bill, what's your response to these sorts of ways of dealing with the fine-tuning?
Well, this is fascinating to me because, as I understand you, Roger, you're not advocating either physical necessity nor chance via the multiverse hypothesis and self-selection effect, nor design, but rather you would simply deny the fact of fine-tuning altogether, that the universe is not fine-tuned for embodied consciousness.
I think deny is too strong. I say I don't know.
You don't know.
Yeah.
And to me, that is highly implausible. We just find example after example of fine-tuning in contemporary physics, and it seems to me to be a desperate expedient to deny that it exists. In the absence of fine-tuning, there wouldn't even be matter. There wouldn't be chemistry. So the idea that other forms of life would evolve, I think, is logically possible, but it's not, I think, the most plausible solution to the problem.
The conditions on Earth and the laws of our universe are not only fine-tuned for life, but apparently also for scientific discovery and technological progress, and the anthropic principle cannot explain this fine-tuning. Although this fine-tuning is not as well documented as the fine-tuning for life, here are some resources which support it. At the end of this video, we'll give the location where you can download the PowerPoint file on which this video is based, and from that PowerPoint file you can click on links like these that we won't look at now. Many scientists are convinced of design by the argument from fine-tuning, but most of them still insist that this designer either could not or did not do anything beyond that. But if you believe a creator designed the laws of nature to make life possible, why exclude a priori the possibility that this creator was still somehow involved after that in the creation of humans, especially when then you are forced to believe that the four unintelligent forces of physics alone could have reorganized the fundamental particles of physics on Earth into nuclear power plants, cars, airplanes, and smartphones.
In a 2000 Mathematical Intelligence or Opinion piece, mathematician Granville Sewell compared the history of his partial differential equation solver to the history of life. He noted that there are large jumps in both, where major new features appear for the same reasons. Gradual development of the new organs or new systems of organs that gave rise to new orders, classes, and phyla would require the development of new but not yet useful features. So Darwinism could not explain the development of these new features even if they did occur gradually. And, according to the fossil record, they don't. Professor Sewell argued that it was inconceivable that sophisticated computer software could be designed by a programmer who, like natural selection, is unable to think ahead more than a few characters at a time. But the whole issue is much simpler than this, and at the end of the piece, he wrote the following. The biologist studies the details of natural history, and when he looks at the similarities between two species of butterflies, he is understandably reluctant to attribute the small differences to the supernatural. But the mathematician or physicist is likely to take the broader view. I imagine visiting the Earth when it was young and returning now to find highways with automobiles on them, airports with jet airplanes, and tall buildings full of complicated equipment such as televisions, telephones, and computers. Then, I imagine the construction of a gigantic computer model which starts with the initial conditions on Earth 4 billion years ago and tries to simulate the effects that the four known forces of physics, the gravitational, electromagnetic, and strong and weak nuclear forces, would have on every atom and every subatomic particle on our planet, perhaps using random number generators to model quantum uncertainties. If we ran such a simulation out to the present day, would it predict that the basic forces of nature would reorganize the basic particles of nature into libraries full of encyclopedias, science texts, and novels, nuclear power plants, aircraft carriers with supersonic jets parked on deck, and computers connected to laser printers, CRTs, and keyboards? If we graphically displayed the positions of the atoms at the end of the simulation, would we find that cars and trucks had formed, or that supercomputers had arisen? Certainly we would not, and I do not believe that adding sunlight to the model would help much. Clearly, something extremely improbable has happened here on our planet with the origin and development of life, and especially with the development of human consciousness and creativity. Of course, constructing such a model is impossible, but Sewell thought imagining it was a useful exercise to get across the point that natural selection, the one unintelligent force in the universe widely credited with the ability to create spectacular order out of disorder, is not a real physical force, and so cannot be included in the simulation, and the point that unintelligent forces cannot explain human intelligence. Rice University chemist James Tour makes a similar point regarding the origin of life. He states, "Molecules don't care about life." Unfortunately, evolutionary biologists are not impressed by such simple arguments. They don't believe you can contribute anything important to the debate without looking at the details of their theories on the origin and evolution of life. They understandably don't believe you can conclude that a complex problem is unsolvable before examining every proposed solution. But mathematicians know that sometimes you can. Let's look at a very simple example. Here is an 8x8 array of squares. It takes 32 dominoes, each of which is a 2x1 rectangle, to exactly cover the 64 squares. If we remove the squares in the upper left and upper right corners, it is easy to exactly cover the remaining 62 squares with 31 dominoes. And there are a huge number of ways to do this, placing some dominoes horizontally and some vertically. This time, let's remove the upper left and lower right corner squares and try to cover the remaining 62 squares again with 31 dominoes. But if you try, you will not succeed. You will probably end up with one domino remaining and two uncovered squares which are not contiguous. You can spend the rest of your life trying different arrangements of the 31 dominoes to exactly cover these 62 squares, but at some point, a mathematician will think, maybe it is possible to prove this problem has no solution. In fact, it is possible, and in this case, it is easy. Think of the 8x8 array as a chessboard and notice that no matter where you put a domino, horizontally or vertically, it will cover one white square and one black square. So dominoes will always cover the same number of white and black squares. But the original chessboard has 32 white and 32 black squares, and the upper left and lower right squares have the same color. So if you remove these two, you will not have the same number of white and black squares to cover. From this viewpoint, it is obvious that there is no solution. Mathematicians are trained to value simplicity. When they have a simple, clear argument and a long, complicated counter-argument full of unverified points, they accept the simple argument, even before they find the errors in the complicated argument. They know the errors must exist, and if they look for them, they will eventually find them. The strongest argument for intelligent design is to clearly state what you must believe to not believe in intelligent design. Materialist scientists have been trying for a long time to explain everything that has happened on Earth without design. And they may in fact be able to explain everything that has happened on other planets without design. But to see that the problem they are trying to solve has no solution, you only need to take the broader view, realizing that they are trying to explain how a few fundamental unintelligent forces of physics alone could have rearranged the fundamental particles of physics on Earth into computers, spaceships, and smartphones. And there is perhaps nothing in all of science that is more clear or more certain than that they could not have.
These forces are very cleverly designed and probably are clever enough to explain chemistry and stars and everything that has happened on other planets, but points 3, 4, and 5 of the 2021 video discuss 3 problems that science must solve to explain how human civilization developed on Earth without further help from this creator. We will see that we're not close to solving any of the three.
It is often claimed that science is close to understanding how the first simple life form arose through entirely natural processes. To see how baseless this claim is, you only have to realize that with all our advanced technology, we are still not close to designing any type of self-replicating machine. That is still pure science fiction. So how could we imagine that such a machine could have arisen by pure chance, even given a universe with fine-tuned laws and a planet with fine-tuned conditions? When we add technology to such a machine to move toward the goal of reproduction, we only move the goalpost, as now we have a more complicated machine to reproduce. Maybe someday human engineers will design a self-replicating machine like we see everywhere in the living world, but it will not happen in my lifetime, and it will not be simple, and it will certainly not show that such a machine could have arisen without design. Materialists believe they already understand how the first living things evolved into intelligent beings, but they really do not have a clue. To appreciate this, you only have to realize that what they are forced to believe is that the four fundamental unintelligent forces of physics alone could have rearranged the basic particles of physics on Earth into tall buildings, computers and cell phones, and airplanes and the internet. As my new video, Why Evolution is Different, brings out, the laws of physics are very cleverly designed and probably can explain everything that has happened on other planets, but they are obviously not clever enough to explain by themselves the development of computers and cars and Apple iPhones. This video also points out how similar the fossil record is to the development of human technology, with obvious similarities between each new invention and previous designs, but with large gaps where major new features appear for the same reasons: gradual development of the new organs that gave rise to new orders, classes, and phyla would require the development of new but not yet useful features. So Darwinism could not explain the development of these new features even if they did occur gradually, and they don't. Here is a picture of 3 children in the 1950s. One of them is me, the other 2 are not. I saw the world from inside one of these children. I saw every picture that entered through his eyes, I heard every sound that entered through his ears, and when he fell on the sidewalk, I felt his pain. How did I end up inside one of these children? This is a question that rarely seems to trouble evolutionists. They talk about human evolution as if they were outside observers and never seem to wonder how they got inside one of the animals they are studying. They consider that human brains are just complicated computers, and so to explain how we got here, they just have to explain how these mechanical brains evolved. But even if they could explain how animals with mechanical brains evolved out of the primeval slime, that would leave the most important question, the one evolutionists never seem to even wonder about, still unsolved. How did I get inside one of these animals?
The first problem is the origin of life. Science still cannot explain the origin of life. Note that the debate between Rice University chemist James Tour and origin of life researchers is over whether or not we are clueless about the origin of life. I'm now going to read a few paragraphs from the beginning of my 2023 Biocosmos article, which is relevant here. With all our advanced technology, we are not close to producing human-engineered self-replicating machines. This is significant because it is widely believed that the first self-replicators on Earth must have arisen through chance chemical processes, it being impossible to appeal to natural selection of replication errors before anything could self-replicate. To better appreciate the enormous difficulties in designing such machines, and thus the difficulties in understanding how the first living things arose on Earth, let's think about what would be required to build, say, a self-replicating Model T car. We know how to build a simple Model T. Now let's build a factory inside this car so that it can produce Model T cars automatically, and call the new car with the Model T factory inside a Model U. A car with an entire automobile factory inside, which never requires any human intervention, is far beyond our current technology, but it doesn't seem impossible that future generations might be able to build a Model U. Of course, the Model U cars are not self-replicators because they can only construct simple Model Ts. So let's add more technology to this car so that it can build Model Us, that is, Model Ts with car building factories inside. This new Model V car, with a fully automated factory inside capable of producing Model Us, which are themselves far beyond our current technology, would be unthinkably complex. But is this new Model V now a self-replicator? No, because it only builds the much simpler Model U. The Model V species will become extinct after 2 generations because their children will be Model Us and their grandchildren will be infertile Model Ts. So back to work, and each time we add technology to this car to move it closer to the goal of reproduction, we only move the goalposts because now we have a more complicated car to reproduce. It seems that the new models would grow exponentially in complexity, and even if we were able to engineer self-replicating cars, it is hard to imagine that without any human maintenance, these cars could keep reproducing themselves for more than a few generations before errors accumulate to the point that all replication halts. And here we have ignored the very difficult question of where these cars get the raw materials they need to supply their factories. Some will object here that the first living things may have been much simpler than self-replicating cars. It is widely believed that you only need to explain how very simple self-replicators could have arisen through chance chemical processes, because then natural selection of the resulting duplication errors could take over and explain how self-replicators far more complex than cars could have arisen. But even if we could explain the appearance of simple self-replicators, imagining trying to design self-replicating cars may help us appreciate the enormity of the difficulties facing any scientific explanation, let alone one which relies on replication errors, for the unimaginably complex self-replicators that we see everywhere in the living world. Then I go on to say, well, let's imagine something much simpler, like a self-replicating cardboard box, and I show that the same thing happens then. The second problem is the evolution from the first life form to complex animals. Darwinists believe they already understand how this happened, but in fact Darwin's implausible explanation for evolution becomes even more implausible with each new biological and biochemical discovery. It is still popular today only because of Leconte's axiom and the fact that evolution doesn't look like the way we think a creator should have designed things, as discussed in the first and second parts of the video, Why Evolution is Different.
Over 130 years ago, University of California geology professor Joseph LeConte summarized the fossil record.
In successive geological faunas, the change seems rather by substitution than by transmutation. Species seem to come in suddenly with all their specific characters perfect, remain substantially unchanged as long as they last, and then die out and are replaced by others. Certainly, this looks much like immutability of specific forms and supernaturalism of specific origin.
LeConte also acknowledges that natural selection cannot explain the appearance of new, irreducibly complex features called novelties in his day.
Neither can it explain the first steps of advance toward usefulness. An organ must be already useful before natural selection can take hold of it to improve on it.
After acknowledging that the only direct evidence, the fossil record, does not support the idea of gradual change, and that the only theory ever taken seriously as to the causes of these changes can explain everything except anything new, LeConte nevertheless concludes,
We are confident that evolution is absolutely certain, not evolution as a special theory, Lamarckian, Darwinian, Spencerian, but evolution as a law of derivation of forms from previous forms. In this sense, it is not only certain, it is axiomatic. The origins of new phenomena are often obscure, even inexplicable, but we never think to doubt that they have a natural cause. For so to doubt is to doubt the validity of reason and the rational constitution of nature.
And so in 1888, LeConte acknowledges what will become clear to anyone who follows the modern debate between Darwinism and intelligent design. Evolution is an axiom, and axioms do not need supporting evidence. A 1980 New York Times article on a meeting at Chicago's Field Museum of Natural History of nearly all the leading evolutionists reports,
At issue during the Chicago meeting was macroevolution, a term that is itself a matter of debate, but which generally refers to the evolution of major differences, such as those separating species or larger classifications. Most agree macroevolution is, for example, what made crustaceans different from mollusks. It is the process by which birds and mammals evolved out of reptiles. Darwin suggested that such major products of evolution were the results of very long periods of gradual natural selection, the mechanism that is widely accepted today as accounting for minor adaptations. Darwin, however, knew he was on shaky ground in extending natural selection to account for differences between major groups of organisms. The fossil record of his day showed no gradual transitions between such groups, but he suggested that further fossil discoveries would fill the missing links. The pattern that we were told to find for the last 120 years does not exist, declared Niles Eldredge, a paleontologist from the American Museum of Natural History in New York. Eldredge reminded the meeting of what many fossil hunters have recognized as they trace the history of a species through successive layers of ancient sediments. Species simply appear at a given point in geologic time, persist largely unchanged for a few million years, and then disappear. There are very few examples, some say none, of one species shading gradually into another.
The New York Times writer assures us, however, that all of this does not suggest weakness in the fact of evolution, only in the perceived mechanism. Even if new features consistently appear suddenly in the fossil record and cannot be explained by natural selection, there is no doubt they were the result of entirely natural causes. That is an axiom that cannot be questioned. LeConte's axiom is the strongest argument against intelligent design. It is certainly understandable that LeConte and other scientists are confident that nothing is beyond the reach of their science. In every other field of science, naturalism has been spectacularly successful. Why should evolutionary biology be so different? To explain why evolution is different, so different that it requires a very different type of explanation, we need to look at what you have to believe to not believe in intelligent design. Peter Urone in College Physics writes,
"One of the most remarkable simplifications in physics is that only 4 distinct forces account for all known phenomena."
But can 4 unintelligent forces of physics alone really rearrange atoms into computers and airplanes and science texts? How did such an implausible theory as Darwinism ever get to be so popular? There are 2 reasons: LeConte's axiom and the similarities between species, which suggest common descent. In many people's minds, these similarities not only prove common descent, they prove that evolution was the result of entirely natural processes, even in the absence of any evidence that natural selection can explain the major steps of evolution. But the similarities do not really tell us anything about the causes of evolution. And there is an alternate explanation for these similarities. Harvard paleontologist George Gaylord Simpson writes,
"It is a feature of the known fossil record that most taxa appear abruptly. They are not, as a rule, led up to by a sequence of almost imperceptibly changing forerunners, such as Darwin believed should be usual in evolution. This phenomenon becomes more universal and more intense as the hierarchy of categories is ascended. Gaps among known species are sporadic and often small. Gaps among known orders, classes, and phyla are systematic and almost always large. These peculiarities of the record pose one of the most important theoretical problems in the whole history of life. Is the sudden appearance of higher categories a phenomenon of evolution or of the record only, due to sampling bias and other inadequacies?
French biologist Jean Rostand wrote,
"It does not seem strictly impossible that mutations should have introduced into the animal kingdom the differences which exist between one species and the next. Hence it is very tempting to lay also at their door the differences between classes, families and orders, and in short the whole of evolution. But it is obvious that such an extrapolation involves the gratuitous attributions to the mutations of the past of a magnitude and power of innovation much greater than is shown by those of today."
In a 2000 Mathematical Intelligencer article entitled A Mathematician's View of Evolution, Granville Sewell wrote the following.
If archaeologists of some future society were to unearth the many versions of my PDE solver which I have produced over the last 20 years, they would certainly note a steady increase in complexity over time, and they would see many obvious similarities between each new version and the previous one. In the beginning, it was only able to solve a single linear steady-state 2D equation in a polygonal region. Since then, PDE-2D has developed many new abilities. It now solves nonlinear problems, time-dependent and eigenvalue problems, systems of simultaneous equations, and it now handles general curved 2D regions. An archaeologist attempting to explain the evolution of this computer program in terms of many tiny improvements might be puzzled to find that each of these major advances, new classes or phyla, appeared suddenly in new versions. For example, the ability to solve 3D problems first appeared in version 4.0. Less major improvements, new families or orders, appeared suddenly in new subversions. For example, the ability to solve 3D problems with periodic boundary conditions first appeared in version 5.6. In fact, the record of PDE-2D's development would be similar to the fossil record, with large gaps where major new features appeared and smaller gaps where minor ones appeared. That is because the multitude of intermediate programs between versions or subversions which the archaeologists might expect to find never existed because, for example, none of the changes I made for edition 4.0 made any sense or provided PDE-2D any advantage whatever in solving 3D problems or anything else until hundreds of lines had been added.
To our modern minds, the similarities between species may suggest natural causes. The argument is basically, this doesn't look like the way God would have created things, an argument used frequently by Darwin in Origin of Species. But if the history of life does not give the appearance of creation by magic wand, it does look very much like the way we humans create things, through testing and improvements. In fact, the fossil record does not even support the idea that new organs and new systems of organs arose gradually. New orders, classes, and phyla consistently appear suddenly. We see this same pattern of large gaps where major new features appear in the history of human technology. For example, if some future paleontologist were to unearth two species of Volkswagens, he might find it plausible that one evolved gradually from the other. He might find the lack of gradual transitions between automobile families more problematic, for example, in the transition from mechanical to hydraulic brake systems, or from manual to automatic transmissions, or from steam engines to internal combustion engines. But if he thought about what gradual transitions would look like, he would understand why they didn't exist. There is no way to transition gradually from a steam engine to an internal combustion engine, for example, without the development of new, but not yet useful, features. He would be even more puzzled by the huge differences between the bicycle and motor vehicle phyla, or between the boat and airplane phyla. But heaven help us, when he uncovers motorcycles and hovercraft, the discovery of these missing links would be hailed in all our newspapers as final proof that all forms of transportation arose gradually from a common ancestor, without design. Some people say, of course cars cannot evolve because they cannot reproduce. Well, designing any type of self-replicating machine is still far beyond our current technology. When we add technology to such a machine to get closer to the goal of reproduction, we only move the goalposts because now we have a more complicated machine to reproduce. So how could we imagine that such a machine could have arisen by pure chance? Nevertheless, imagine that we did manage to construct a fleet of cars that contained completely automated car-building factories inside, with the ability to construct new cars, and not just normal new cars, but new cars containing automated car-building factories inside them. If we left these cars alone and let them reproduce themselves for many generations, is there any chance we would eventually see major advances arise through natural selection of the resulting duplication errors? Of course not. We could confidently predict that the whole process would grind to a halt after a few generations without intelligent humans around to fix the mechanical problems that would inevitably arise, long before we saw duplication errors, which held any promise of advances. Devolution is natural. Evolution is not. That it seems even superficially plausible that random mutations could produce major improvements relies completely on the observed but inexplicable fact that while they are awaiting rare, favorable mutations, living species are able to preserve their complex structures and pass them on to their descendants without significant degradation, generation after generation. We are so used to seeing this happen that we don't appreciate how astonishing it really is. But if we saw cars reproducing themselves, generation after generation, we might conclude that this actually made the development of cars even more difficult to explain without design. The similarities between the history of life and the history of technology go even deeper. Although the similarities between species in the same branch of the evolutionary tree may suggest common descent, similarities also frequently arise independently in distant branches where they cannot be explained by common descent. For example, in their Nature Encyclopedia of Life Sciences article on carnivorous plants, Wolf-Eckhard Lenig and Heinz Albert Becker note that
carnivory in plants must have arisen several times independently of each other. The pitchers may have arisen 7 times separately, adhesive traps at least 4 times, snap traps 2 times, and suction traps possibly also 2 times. The independent origin of complex, synorganized structures, which are often anatomically and physiologically very similar to each other, appears to be intrinsically unlikely to many authors, so that they have tried to avoid the hypothesis of convergence as far as possible.
These carnivorous traps, by the way, are all good examples of irreducible complexity. Many features must work together almost perfectly before they can catch and digest victims. Convergence suggests common design rather than common descent. The probability of similar designs arising independently through random processes is very small, but a designer could, of course, take a good design and apply it several times in different places to distantly related species. For example, to give bats and dolphins echolocation abilities. Convergence is a phenomenon often seen in the development of human technology. For example, Ford automobiles and Boeing jets may simultaneously evolve similar new GPS systems. The history of life on Earth appears strikingly similar to the way humans design things, through careful planning, testing, and improvements. As intelligent designers ourselves, we should recognize it when we see this in nature.
A 2022 article in The Guardian shows that the objections to Darwinism raised in this video are still valid today. Strange as it sounds, scientists still do not know the answers to some of the most basic questions about how life on Earth evolved. Take eyes, for instance. Where did they come from exactly? The usual explanation of how we got these stupendously complex organs rests upon the theory of natural selection. You may recall the gist from school biology lessons. If a creature with poor eyesight happens to produce offspring with slightly better eyesight thanks to random mutations, then that tiny bit more vision gives them more chance of survival. The longer they survive, the more chance they have to reproduce and pass on the genes that equip them with slightly better eyesight. Some of their offspring might in turn have better eyesight than their parents, making it likelier that they too will reproduce, and so on. Generation by generation, over unfathomably long periods of time, tiny advantages add up. Eventually, after a few 100 million years, you have creatures who can see as well as humans or cats or owls. This is the basic story of evolution, as recounted in countless textbooks and pop science bestsellers. The problem, according to a growing number of scientists, is that it is absurdly crude and misleading. For one thing, it starts midway through the story, taking for granted the existence of light-sensitive cells, lenses, and irises without explaining where they came from in the first place, nor does it adequately explain how such delicate and easily disrupted components mesh together to form a single organ. And it isn't just eyes that the traditional theory struggles with. The first eye, the first wing, the first placenta, how they emerge. Explaining these is the foundational motivation of evolutionary biology, says Armin Moksek, a biologist at Indiana University, and yet we still do not have a good answer. This classic idea of gradual change, one happy accident at a time, has so far fallen flat. The carnivorous plants are all good examples of irreducible complexity, that is, of features which would not make any sense to evolve gradually. One of them is described in Plants and Environments as follows. The aquatic bladderworts are delicate herbs that bear bladder-like traps 5 millimeters or less in diameter. These traps have trigger hairs attached to a valve-like door, which normally keeps the trap tightly closed. The sides of the trap are compressed under tension, but when a small form of animal life touches one of the trigger hairs, the valve opens, the bladder suddenly expands, and the animal is sucked into the trap. The door closes at once, and in about 20 minutes, the trap is set ready for another victim. Irreducible complexity is ubiquitous in living things, and especially at the microscopic level. But Darwinists can usually imagine 2 or 3 far-fetched, useful intermediate stages and consider the problem solved. The carnivorous plants are special only in that, quote, it appears to be hard even to imagine clear-cut selective advantages for all the thousands of postulated intermediate steps in a gradual scenario for the origin of the complex carnivorous plant structures examined above, according to 2 scientists at the Max Planck Institute for Plant Breeding Research. The third problem is the origin of intelligent, conscious humans. If you believe that humans are the result of a purely mechanical process such as natural selection of random mutations, you are forced to believe that we are just machines. But I am not just a machine, so even if unintelligent forces could explain the appearance of complex animals, these forces cannot explain how I got inside one of those animals. The final point in my 2021 video is about the Big Bang, which tells us that the universe had a beginning, and since there were no natural causes before nature came into existence, science cannot ever hope to explain this beginning. Notice that if it is hard to believe that the universe had a beginning, it is equally hard to believe it did not. For example, if it were infinitely old, shouldn't all stars have burned out long ago? How long ago? 1 trillion years ago? Why not long before that?
For thousands of years, nearly everyone in every corner of the world looked at plants and animals and said, these things are obviously designed. I wonder who designed them. Only the modern scientist, overconfident from so much success in unraveling other mysteries, says, these things sure look like they were designed, and the deeper we dig, the more designed they look, but who designed the designer? Nothing can possibly be beyond the reach of our science, so if we can't explain where the designer came from, he can't exist. For many years, materialists avoided the parallel question of who designed matter and energy by saying they have always existed. But in the last century, it was discovered that matter and energy and space and time did begin suddenly with a Big Bang about 14 billion years ago. What came before the Big Bang? Even if before the beginning of time, as we know it, is not meaningful in a temporal sense, it is still meaningful in a causal sense. It's because out of nothing comes nothing. There has to be some first cause. Whether this first cause is intelligent or unintelligent, there is by definition no hope of ever explaining it in terms of earlier causes. Materialists can say that their currently preferred universe-generating mechanism needs no explanation because it is eternal, but we can equally say our designer needs no explanation because he is eternal. So why not assume a first cause that can explain what was caused? A well-designed universe with physical laws that are extremely fine-tuned for the magnificently designed plants and animals, and intelligent, conscious humans that arose on our magnificent earth.